Other than being proportional, another way that quantities can maintain the same relationship as each quantity changes is to change at the same rate. What is a rate of change? The rate of change of one quantity relative to another is the change in the dependent quantity over the change in the independent quantity. When we describe a rate of change, we describe it as being the rate of change in a dependent quantity relative to the change in an independent quantity. So, for example, at 6 a.m., the temperature was 41 degrees Fahrenheit. By 11 a.m., the temperature was 73 degrees Fahrenheit. What was the rate of change in the temperature relative to the time? Now, recall what we said in the past, that change is final minus start. For temperature, the change is the final temperature, that's 73 degrees, minus the starting temperature, that's 41 degrees. Subtracting, we get that the change in temperature was 32 degrees Fahrenheit. For the time, these are different times in the morning of the same day, so we can really do arithmetic to them. The change is 11 o'clock minus 6 o'clock equals 5 hours. And so the rate of change is the change in temperature over the change in time. We could simplify this if we liked, but we don't have to. Now, sometimes the way that the problem is given to us, we aren't told the final and starting values, we're just told the change. So, for example, we might be told that Janice drove 180 miles in 4.5 hours. What was the rate of change of distance relative to time? The 180 miles she drove, well, she went from having driven 0 to having driven 180 miles. So this 180 miles is the change in distance. This 4.5 hours is the change in time. So the rate of change is 180 miles per 4.5 hours. And again, we could simplify this like any ratio. We could, for example, see that this is a complex fraction, so we'd like to write it as a division problem. Let's see, 4.5, that's 4 times 2 plus 1 halves. That's 8 plus 1 halves, or 9 halves. So this is 180 wholes divided by 9 halves. 180 wholes times 2 ninths. 180 times 2 over 9. I noticed that 9 is a factor of 180. Since 9 goes into 18 twice, so 9 goes into 180 20 times. So we end up with 40 wholes, 40 over 1, leaving it written in fraction form, of course, because it's a ratio. We'll say 40 miles for every 1 hour is the simplified ratio. Now, sometimes we won't be told explicitly what our independent and dependent quantities are. We'll need to figure them out from context. For example, suppose we're told that Julia earns $450 one week working 39 hours. What is her rate of pay? So again, these amounts are the changes. The number of dollars she had earned started at 0. The number of hours she had worked started at 0. It seems likely that the time that she worked is the independent quantity. She can easily look at her watch and tell how many hours she's worked. What she wants to predict based on how much she's worked is how much she's going to get paid. So the rate that we want to write is $450 for every 39 hours. Let me give you one of these to try, one of this last kind, where you have to decide on your own what the independent and dependent quantities are. Suppose a town's population goes from 18,225 to 16,350 in 4 years. What is the rate of change? Pause the video and try this now. Okay, so again, it looks like the thing that is easy to keep track of is the passage of time. The time is going to be the independent quantity. And we're just told the change in the time, rather than being told where we start and where we end. The change is 4 years. The dependent quantity, then, will be the population. And that change we're going to need to calculate. It'll be the final value minus the starting value. Oh, it looks like this is a job for signed subtraction, isn't it? Because this is smaller minus bigger. How do we do that again? Right, our first move is to rewrite this as adding the opposite. If you didn't spot that this was a job for signed subtraction, you can pause the video and try to finish this on your own if you'd like. All right, so now we're adding a positive plus a negative, opposite signs, so what we want is subtraction. The negative one is bigger, so our answer is going to be negative. We actually work out the subtraction in the order that works, bigger minus smaller. 5, borrow, 7, borrow, 8, 1. Negative 1,875 is the change in the population. So the rate of change then is negative 1,875 people in 4 years.